Here's another quadratic equation. The reason we know it's a quadratic equation, highest power of the variable in the equation is 2. Second degree or quadratic equation. Our method for solving this kind of equation involves factoring. The equation must be in standard form. Standard form says all of the terms of the polynomial are on one side, 0 on the other side. We don't have standard form with this equation. We need to first put the equation in standard form. What I can do to make that happen is to subtract 20 from both sides. Now my left-hand side of my equation is 2x squared minus 6x minus 20. The right-hand side of the equation is now 0, and I'm ready to start factoring that polynomial. Remember, you always look for a common factor when you start factoring. And there is a common factor here. Every one of those terms is divisible by 2. So we will divide out that common factor of 2. Put the 2 out in front of the parentheses and divide each of those terms by 2 and write the quotient as you perform the divisions inside the parentheses. 2x squared divided by 2 leaves x squared as a quotient, as an answer. Minus 6x divided by 2 gives us minus 3x. Minus 20 divided by 2 gives us minus 10. And we have factored out the common factor, which should make it easier, a little less complicated, to continue factoring that trinomial. Trinomials, if they factor into the product of two binomials. The sign here is a subtraction. The only way that happens is to have a plus times a minus in the binomials. That's how we get a minus under the L of FOIL. It was a plus times a minus. So that tells us that one of our signs needs to be an addition, and the other sign needs to be a subtraction in our binomials. How do we get x squared? Well, that would be x times x is the only way we're interested in. How can we make a 10? That would be 1 times 10, 2 times 5. And let's try the 2 here and the 5 here. And that will give us minus 3x. The O of FOIL would give us minus 5x. The I of FOIL is going to give us plus 2x. And those two combine to the minus 3x that we need. Now we perform our analysis. What values could x take on that would cause either x plus 2 to become 0 or x minus 5 to become 0? Because if one of these quantities becomes 0, the entire product will be 0, which makes it the same as the right side, which makes a solution. Remember, solutions to equations always make the left side of the equation become the same as the right side. In this case, we're wanting to make the left side become 0. That would happen if x was negative 2, wouldn't it? Negative 2 plus 2 would be 0. 0 times anything would be 0. Or if x was 5. 5 minus 5 is 0. 0 times anything is 0. We have our two solutions.